Welcome to my channel. We'll be discussing the first part of permutations and combinations in this session. And we'll be discussing about the fundamental rule, or what we call it as multiplication rule. What is this fundamental rule? If one activity can be performed in m ways, another activity can be performed in n ways, then the number of ways of performing both activities is m into n ways, m into n, the product. That's why this is called multiplication rule. For example, if there are 3 shirts and 2 trousers, the number of ways of selecting a shirt and a trouser is 3 into 2 6 ways, not 3 plus 2. It is 3 into 2 because for every shirt that is selected, you have 2 options of selecting a trouser. For 3 shirts, it will be 2 plus 2 plus 2, we have 6. 2 plus 2 plus 2, you are adding 3 times, means rather it is nothing but 3 into 2, 6 ways. I have 3 options to select a shirt. For every shirt we selected, we have 2 options of selecting a trouser. So total number of ways will be 3 into 2, 6 ways. Let's take up one more example. City P and city Q are connected by 4 different roads, and city Q and city R are connected by 3 different roads. How many different routes a person can choose to travel from city P to city R via city Q? We have city P, city Q and city R, and P and Q are connected by 4 different routes, and Q and R are connected by 3 different routes. So here 4 options, 3 options means the number of ways a person can travel from P to R, the number of different routes he or she can choose will be equal to 4 into 3, 12 options. As I just explained in the previous question, for every route he selects from P to Q, he has 3 options to go. So for 4 routes, 4 into 3, total 12 options we have. Let's take up one more example. How many 4-digit positive integers are there? If you look at positive integers, 4-digit numbers, ones place, tens place, hundreds place, and thousands place. And to write the numbers here, we use the digits from 0 to 9. So to fill this units place, I can fill this with any of these 0 to 9, 10 digits. For this tens place, again I can fill anything from 0 to 9, I have 10 options. For this hundreds place also, anything from 0 to 9, 10 options. But for this leftmost digit, we cannot fill this with 0, because if the leftmost digit is 0, suppose 0375 if I have, can we call it a 4-digit number? No, because this leftmost digit 0 means this is nothing but 375. It is only a 3-digit number. So if you have to call this as a 4-digit number, the leftmost digit cannot be 0. It has to be some other digit. So hence, to fill this leftmost place, the thousands place, we cannot fill this with 0, but we can fill this with any of the other 9 digits. So 9 options I have. Total, we have 9 into 10 into 10. We have total 9,000 4-digit numbers are there, right? So this is the fundamental principle of multiplication. Each activity is independent. So when all these activities can be performed means it is the product of them. 9 into 10 into 10, it will be 9,000 ways, right? We'll discuss the concept of selections. This is the second part of this permutations and combinations videos. What is a selection or a combination? Let's take a couple of examples. Suppose if I have 3 persons by name A, B, C. Out of these 3 people, if I want to select 2, how many different selections we have? We can select AB, we can select AC, or we can select BC. So we have 3 selections. 3 selections, or we have 3 different combinations. Selections and combinations are one and the same. Now, for example, if I have 4 people, A, B, C, D. If I want to select again 2 people, what are the different combinations possible or different selections? One combination can be AB, AC, AD, or it can be BC, or it can be BD or CD. There are 6 selections or 6 combinations possible. But now we cannot afford to list like this. If it is 3 people or 4 people, we can afford to list out like this. If there are say 10 persons and if I want to select 3 people, we can't write all possible combinations. Then how are we going to take up? There is a formula. Here we are selecting 2 people out of 3 people, means we say 3C2. A combination of 2 out of 3. Here we are selecting 2 people out of 4 means, rather we are looking for a combination of 2 people out of 4 means we say 4C2. So how do we calculate this? Means there is a formula. The formula is number of ways of selecting R items out of N items is NCR. This NCR equals to N factorial by N minus R factorial into R factorial. For example, if I take the earlier example, selecting 2 people out of 3 means we say 3C2. If I write 3C2, 3 factorial by 3 minus 2 factorial into 2 factorial. It is 3 factorial by 3 minus 2, 1. 1 factorial into 2 factorial means it is 3 into 2 into 1 by 1. This is 2 into 1. You can see the answer is 3. Or 4C2 means 4 factorial by 4 minus 2 factorial into 2 factorial means it is 4 into 3 into 2 into 1 by 4 minus 2, 2 factorial is 2 into 1. Similarly, 2 factorial is 2 into 1. You can see 2 2's 4, 4 gets cancelled. My answer is 6. I just asked you, how many selections are there? If I want to select 3 people out of 10, I said 10C3. So 10C3, obviously we have to use formula. We can't write all the list there. If I apply this formula 10C3, what is 10C3? Selecting 3 persons out of 10. So it will be 10 factorial by 10 minus 3 factorial into 3 factorial. If you observe here, see 10 factorial by 7 factorial into 3 factorial means 10 factorial means 1 to 10, 7 factorial means 1 to 7. So 1 to 7 will get cancelled. What will be left over is 10 into 9 into 8. See what I am saying is this 7 to 1 here, and in this 7 factorial 7 to 1 will get cancelled, I am saying, into 3 factorial is 3 into 2 into 1. See this gets cancelled. That's why I am writing 10 factorial by 7 factorial means 1 to 7 gone means 10 into 9 into 8 by 3 into 2 into 1. That is for this 3 factorial. You can see 3 3's, 2 4's, 3 4's 12, 12 10's 120. Right? This is about selecting R items out of N items, which we call NCR. A few important points on these selections. First one, factorial 0 is 1. So factorial 0 value is 1. It's not 0. Second one is NC0 equals to 1. See, we said NCR equals to N factorial by N minus R factorial into R factorial. What happens here? N factorial by N minus R. R is 0 means N minus 0, N minus 0 will be N only. N factorial into 0 factorial. As I said, N factorial gets cancelled. Factorial 0 is 1. That's why we say it can be NC0 can be equal to 1. Right? Now, similarly, N equals to 1, same thing happens. NCN means it is N factorial by N minus N factorial into N factorial means this gets cancelled. N minus N 0 factorial 0, that is 1, it will be 1. And one more important point is NCR equals to NCN minus R. For example, if I take NC, say, let us say 9C5 equals to, as per this rule, I am saying 9C, 9 minus 5, that is 9C4. Let me show you. If I take 9C5, if I apply this NCR formula, it will be 9 factorial by 9 minus 5, 4 factorial into 5 factorial. That's about NCR, that is 9C5. If I take 9C4, 9 factorial by 9 minus 4, 5 factorial into 4 factorial. Are they not same? Yes. So that's why we have, this is a very useful rule, NCR equals to NCN minus R. Suppose if I take 10C7, if I take 10C7 is nothing but 10C, 10 minus 7, 3. In the previous case, we calculated 10C3, so 10C7 value is also same, right? So these are few important basic concepts of selections or combinations. We will discuss the second part of selections or combinations. In the first session, we have discussed the basic concepts of combinations or selections. We have discussed the basic formulae and how to calculate them and all that. In this session, we will apply those formulae, those basic concepts, and solve different types of questions. And this is the third in the series of these permutations and combination videos that we are making. The first question, find the number of ways of selecting a team of 3 persons from 6 men and 4 women. We have 6 plus 4 total 10 persons and we need a team of 3 persons. Here, there is no specification that the team should have this many men or this many women. Since there is no condition as such, it is as good as simply selecting 3 people out of 10 people, that is 10C3. Selecting 3 persons out of 10 is 10C3, and you know NCR formula is n factorial by n minus r factorial into r factorial. If I apply the formula here, 10 factorial by 10 minus 3, 7 factorial into 3 factorial. 10 factorial by 7 factorial will be 10 into 9 into 8, because 1 to 7 here, 1 to 7 here will get cancelled. By 3 factorial, 3 into 2 into 1. 3 threes, 2 fours, 10 threes, 30 into 4, 120. So the total number of ways is 120. Total number of selections possible, we have here 120. Let's take up next one. Find the number of ways of selecting a team of 5 persons from 6 men and 4 women such that a particular man and a particular woman should be there always. Should get selected by themselves. That means out of total 10 persons, you have to select 5 people, but one particular man here and one particular woman. So for 2 people, you have no option but to select them. That means out of 10 people, only 8 people you have some choice of either selecting or not selecting. Since I need to select 5 people, out of which already 2 people are definitely there, so we have to only select remaining 3 people. So it is like selecting 3 persons out of the 8 people. Out of 10, 2 are definitely there. So the remaining 8 people, from 8 people, I have to select. Out of 5, 2 already got selected, means I have to select 3. 8C3. 8C3 is nothing but 8 factorial by 8 minus 3, 5 factorial into 3 factorial. 8 factorial by 5 factorial is 8 into 7 into 6. Because again 1 to 5 here, 1 to 5 here will get cancelled by 3 into 2 into 1. 3 to 6, 6 gets cancelled. My answer is 56. Let's take up one more. There are 8 batsmen, 3 wicket keepers and 7 bowlers available for selection. How many ways a team of 11 players can be selected such that the team consists of 5 batsmen, 1 wicket keeper and 5 bowlers? We have how many batsmen here? 8 batsmen, and we have wicket keepers 3, and we have bowlers 7, and we need to select how many people? 11 people. But what should be the composition? There should be 5 batsmen, 1 wicket keeper and 5 bowlers. Out of 8 batsmen, you have to select 5 batsmen, means number of selections is 8C5. Out of 3 wicket keepers, 1 should be selected, means 3C1. And out of 7 bowlers, we need to select 5 bowlers, 7C5. If you multiply 8C5 into 3C1 into 7C5 is the total number of options. Because if you recollect the first class, if one job can be done in m ways, another job can be done in n ways. How many ways both can be done means m into n ways. The fundamental principle or the multiplication principle. Similarly, we have to select these 5 batsmen and 1 wicket keeper and 5 bowlers, means all these 3 have to happen, means total number of options are 8C5 into 3C1 into 7C5. 8C5, if you calculate, it will be 56. 3, you know how to calculate, you know the formula, NCR formula, you can do the calculation. 3C1 is 3, 7C5 will be 21, 7 into 6 by 2, that is 21. So now 21 into 3, 63, 63 into 56 means if you multiply this 6 3 is 18, 3 5 is 15 plus 1 16 plus 6 36 52, 6 5 is 30, 3 5 2 8. So the total number of options I have is 3 5 2 8. Let's take up one more example. Find the number of ways of selecting a committee of 5 persons from 5 men and 3 women such that the committee consists more men. You should have more men than women. See, now I need a committee of 5 persons and we need more men means out of 5 men and 3 women, probably we can have all men. So what are the options I have? There are 3 possibilities. One option is I need a committee of 5 people, all 5 can be men. This is one option. Second, there can be 4 men and 1 woman. Out of these 5 persons, I have to select. Third option, there can be 3 men and 2 women. That's it. Because the fourth option is not there because it can't be 2 men and 3 women because we need more men. So these are the possibilities. Either this, I should have either this possibility or this possibility or this possibility. Now, how many ways I can select 5 men? Out of 5 men, I have to select 5 men means 5C5, that is 1. Out of 5 men, I have to select 4 men means 5C4 into out of 3 women, 1 woman will be 3C1. As I have already said, 5C4, you know how to calculate. I'll take directly 5, 3C1, 3, 5 into 3, 15. Next, the third option I have is out of 5 men, I have to select 3 men means 5C3. Out of 3, 2 means 3C2. 5C3 is 10, 3C2 is 3, total 30 options. So now the question is all these 3 options don't exist. Either this or this or this. It's not this and this and this. So either I have a committee of 5 men or I have a committee of 4 men and 1 woman or I have a committee of 3 men and 2 women. When we have or, we should add it. And means you should multiply. So it will be 1 plus 15, 16 plus 30. Total we have 46 options. Right? So these are few examples on selections. We will discuss arrangements or permutations first part. This is the fourth in the series of videos that we are making on permutations and combinations topic. Arrangements or permutations. Let's discuss this with an example. If there are 5 persons, if they are to be seated in a row, what are the different number of arrangements or permutations? Let's see. If I take the first position, leftmost position, how many options we have? Any of these 5 persons can be seated here. We have 5 options for this place. To the next place, since one person is already sitting here, there are 4 other persons. We have 4 options. Any of the 4 guys can sit here. To the third one, since 2 persons already seated in the first 2 places, still 3 persons are left over. Any of the 3 persons can be seated here. We have 3 ways or 3 options. To the fourth one, since 3 persons already seated, we have 2 persons left over. Any of those 2 persons can be seated. So we have 2 options. And coming to the last position, there is only 1 person left over. That person will sit here. There is only 1 option. So the total number of options means, you know, from the earlier sessions, the multiplication principle, the total number of options we have is 5 into 4 into 3 into 2 into 1. It is 5 factorial, or we can say it is 120. 5 4 20, 60, 120. So students, we can say that if 5 persons are there, they can be arranged in 5 factorial ways. So if there are n items, number of ways of arranging n items in a row is n factorial. Number of ways of arranging 5 persons in a row is 5 factorial. Right? Okay, let's take up one more concept. Now students, I have 5 persons, but if there are only 3 positions, 3 chairs to be occupied, how many ways we can arrange people in these 3 chairs means, if you look at the first chair, there are 5 persons. Any of the 5 persons can be arranged here. So we have 5 options. To the second chair, since 1 person is already sitting, the remaining 4 people, any of the 4 persons can be seated here. 4 options. Since 2 persons gone, for the remaining chair, there are 3 persons left over. Any of the 3 persons can be seated. So the total number of options is m into n into p. The multiplication principle or fundamental principle we have discussed in the first session. 5 into 4 into 3, that is 60 options. This is one way of explaining that. Another way of explaining this is, this has got actually two stages. First, out of 5 persons, only 3 persons are going to be seated. It means you have to select 3 persons out of 5 persons. How many ways I can select 3 persons out of 5 means, if you see from the earlier sessions on selections and combinations, we say 5C 3 ways. So out of 5 persons, 3 persons can be selected first in 5C 3 ways. Once you select those 3 persons can be seated in these 3 positions in how many ways means, as I've just said, 3 persons in 3 positions can be seated in 3 factorial ways. So the total number of options is 5C3 into 3 factorial. And what is NCR formula? You know, NCR formula is n factorial by n minus r factorial into r factorial. So 5C3 equals to 5 factorial by 5 minus 3 factorial into 3 factorial. This is 5C3 into 3 factorial. If I do, you can see 3 factorial gets cancelled. It will be 5 factorial by 5 minus 3 factorial. So it is 5 factorial by 2 factorial. 5 factorial, you know, is 120 by 2 factorial 2. My answer is 60. Right? So now here we are not arranging all 5 people. We are arranging only 3 persons. So the number of ways of arranging r items out of n items will be, arranging r items out of n items will be NPR. As I said, this has got two stages. First, we have to select r people out of, like we are selecting 3 people out of 5. We have to arrange r items out of n items means first, then I have to select them in NCR ways, like I selected 5C3 ways. Then those R people who are selected, or R items that have been selected, can be arranged in R factorial ways. It is NCR into R factorial. If you recall here, NCR equals to n factorial by n minus R factorial into R factorial into R factorial. If I do it like 3 factorial is getting cancelled, R factorial gets cancelled. That's why we say, students, NPR equals to, you can see, n factorial by n minus R factorial. So arranging 3 persons out of 5 persons will be 5P3. We can directly say, instead of writing all these 5P3, which is 5 factorial by 5 minus 3 factorial, which is 5 factorial by 2 factorial, which is 120 by 2, 60. Right? Okay. Next. What if 5 persons have to be arranged in a circular table? If I have to arrange them around a table in a circular arrangement, how many ways we can arrange these 5 persons means? Students, here there is no end. Who is sitting leftmost? If it is a row, who is sitting on the left position, who is sitting on the right position will make difference. Since it is a circle, first you take one person and make him sit anywhere. Suppose if one person is sitting here. So who will sit here means, how many options I have? If one person is sitting, to someone to sit right of him, there are 4 options. Any of the remaining 4 people can be seated. And suppose if one more person has to be if one person is sitting here, how many options are there to someone to sit here means, so there are 2 persons already gone 3 ways. For one more person here, it is 2 ways, because only 2 persons are left, and here one way. So it is 4 into 3 into 2 into 1. It is 4 factorial ways. In other words, because there are 5 persons, one person you have to fix first position and then arrange them. We say it is 5 minus 1 factorial, or in other words, we can say it is 4 factorial, which is 24. So what we can conclude out of this is, number of ways of arranging n items around a circular table is n minus 1 factorial. Right? Students, here when you are arranging them, who is sitting here makes difference. That means who is sitting right of him or left of him matters, or clockwise or anti-clockwise matters. However, if you look at a garland which is a hanging item, so whether it is clockwise or anti-clockwise doesn't matter, because it looks from, if suppose something is hanging, from which side you are looking matters. So that's why the clockwise and anti-clockwise is not important. So hence we say Number of ways of arranging n flowers in a garland is n minus 1 factorial by 2. The common mistake we do is we think that garland is like a circular arrangement. We may say n minus 1 factorial, but please remember it is a hanging item. So it is n minus 1 factorial by 2, right? So these are few important points on permutations and arrangements. We'll discuss the second part of arrangements or permutations. In the first part, we have discussed the basic concept and formulae. We'll apply them and answer a few questions in this session. And this is the fifth in the series of permutations and combination videos that we are making. The first question, in how many ways 5 men and 5 women can be arranged in a row? 5 men and 5 women, total we have 10 persons. 10 persons can be arranged in a row in 10 factorial ways. N persons or n items can be arranged in a row in n factorial ways. So 10 persons can be arranged in 10 factorial. Here, there is no difference between man or a woman because here there is no condition as such. So it's a simple question of 10 persons being arranged. So answer is 10 factorial. However, if you look at the next question, in how many ways 5 men and 5 women can be arranged in a row such that all men sit together? All men sit together means we'll take all 5 men as one unit, 5 women as 5 different units. So total we have 2, 3, 4, 5, 6 different units. As you know, 6 different units can be arranged in 6 factorial ways. However, these 5 men who are sitting together in this here, how they can be sit, though they are together within those 5 men, within this 5 men group, how many ways they can be arranged? So they can be arranged in 5 factorial ways. In this group, these 5 men can be arranged in 5 factorial ways. Hence my answer is 6 factorial into 5 factorial. Now, same thing we can say for women sitting together also. In how many ways 5 men and 5 women can be arranged in rows is that all women sit together means we say all women belong to one group, we say one unit, and 5 men will be 5 different units. Total we have 6 units. 6 units can be arranged in 6 factorial ways. As I said, within this group, these 5 men, though 5 women, though they are together, they can be arranged within among those women, they can be arranged in 5 factorial ways. So my answer is 6 factorial into 5 factorial. Let's take the next one. In how many ways 5 men and 5 women can be arranged in a row such that all men sit together and all women sit together? So all men will be one group, all women will be one group. So these two groups can be arranged in 2 factorial ways. However, as we discussed in the previous questions, within this group of men, these 5 men can be arranged in 5 factorial ways within this group, and these 5 women can be arranged in 5 factorial ways. So total number of options will be 2 into 5 factorial into 5 factorial. 5 men in 5 factorial ways, 5 women 5 factorial ways. So total is 2 factorial into 5 factorial into 5 factorial. Let's take up one more. In how many ways 5 men and 5 women can be arranged in a row such that no 2 men sit together? That no 2 men sit together. Men cannot sit together. Okay, first we'll take 5 women. 5 women can be arranged in how many ways? For women, there is no condition here. 5 women can be arranged in 5 factorial ways. Now, men cannot sit together means they should be sitting between men, we should have women here. So, a man can sit here. There is one place here. Second place, third place, fourth place, fifth place, sixth place. In these 6 places, if they can be seated, no 2 men are together. So there are 6 possible places, but we have 5 men means in 6 places 5 men can be arranged in 6p5 ways. So my answer is 5 factorial into 6p5. Same way we can say for women sitting together also. 5 men and 5 women can be arranged in a row such that no 2 women sit together means. So first let us say 5 men can be arranged in 5 factorial ways. Now 1 place, 2, 3, 4, 5, 6. If women sit in these places, In these 6 places, if they sit, they are not sitting together. So we can say that they can be seated in 6 places, but only 5 women are there. My answer is 6p5. Same answer, right? Let's take one more. In how many ways 5 men and 5 women can be arranged in a row such that men and women sit alternately? So we have a man followed by woman, then man, woman. So like this, they should sit alternately. So if you see like this, so these 5 men can be arranged in 5 factorial ways. Then these 5 women can be arranged in 5 factorial ways. But however, why should we say start the row with the man? We can start the row with the woman also. So who sits first? Is it a man or a woman? There are 2 options for me. So you can say woman followed by man, woman followed by man. Like this also we can have. So who sits in the first place, man or woman? We have 2 options. That's why total number of options are 2 into 5 factorial into 5 factorial. We have 5 factorial into 5 factorial here. Here, when you add them, 2 times of 5 factorial into 5 factorial. So this is the total number of options. So these are few examples on arrangements. We'll discuss a few practice questions from permutations and combinations. And this is the 6th video that we are making in this series. The first question. Find the number of ways the letters of the word management can be arranged. If I write the management here, it is a 10-letter word. You can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. 10 letters can be arranged in 10 factorial ways. However, here a few letters have been repeated. For example, M is repeated twice. M comes twice here. Suppose if there are 2 different letters A and B, what are the possible arrangements? Means AB is one arrangement, BA is another arrangement. It's possible. 2 arrangements are possible. If both are same letters, say M and M, we can have only one arrangement. It cannot be 2 different arrangements. That's the reason, because it is repeated, the number of arrangements will come down. Since M comes 2 times, so we have to divide this by 2 factorial, because to that extent arrangements will come down. Similarly, A repeats twice, so divide by 2 factorial. Next, N also repeats twice, divide that by 2 factorial. And the G is not repeated, again E is repeating, yes, another 2 factorial. So G and T are not repeating, so we will not take this. So hence my answer is 10 factorial by 2 factorial 4 times means it is 2 factorial whole power 4. My answer is choice C. Right? Let's take up one more. In how many ways can 5 letters be posted in 7 boxes? 5 letters and we have 7 boxes. Let's take letter 1. To post letter 1, how many options I have? There are 7 boxes, means in any of these 7 boxes, we can post the first letter. So there are 7 options. For letter 2, similarly, again letter 2 can be posted in any of the 7 boxes, 7 options like this. Letter 5 also we have 7 options. So for every letter there are 7 options. There are 5 letters, means we have to say 7 into 7 into 7 5 times. In other words, my answer is 7 power 5. So answer is choice C. I repeat, for every letter there are 7 options. For 5 letters, 7 into 7 into 7 5 times 7 power 5. Choice C. Let's take up one more. There are 20 questions in examination. The answer for each question has 4 multiple choice options. That means for this question, for each question there are 4 multiple choices. So the student has to select any one of them. Now, in how many ways can a student attempt the examination if the student can leave a question unanswered? Now, if you look at for every question, how many options a student has? So, for example, if he takes up question 1, he can mark any of these 4 options, or he may not attempt it all. He may not attempt it all. He may leave it also. One more option he has is leaving. So that means for every question he has 5 options, either to choose one of these 4 options or to leave the question. So for every question he has 5 options. So then for every question there are 5 options. Question 2 also you can exercise 5 options. Question 3 also you can exercise 5 options, and so on. So for 20 questions, how many options I have? Means 5 into 5 into 5, 20 times because there are 20 questions. 5 into 5 into 5, 20 times means my answer is 5 power 20. So answer is choice B. Right? Students, please do subscribe to my channel so that you can get all the new videos on quant. Thank you.